go. 64 gigabytes. Get available memory. We're sysadmining it up. Let's freaking go. Too hype for a basic sysadmin app. So as a dev, and then on top of that, as a dev that uses NeoVim, I spend even more time in the terminal. And on top of that, as a dev who uses NeoVim and also specializes in the cloud and DevOps space, I mean, I'm in the terminal like all the time. Now, as a consequence of this, I end up interfacing with some sort of Linux-y shell, whether that's on my Mac or on a Linux box or whatever, extremely often, because I mean, that's how you interface with the terminal in the first place. So as I'm interfacing with the terminal, I kind of have developed this feel for, hey, if I'm just gonna write a little bash script that's just a few lines with a few commands, and I kind of have this feel for when that becomes a little too many commands, right? Like if I need some features from a general programming language, like my programming language of choice, which would be Golang. I think we all kind of do this as devs, like especially if you even use bash at all. There's a lot of people who don't really use bash, but if you're in the DevOps and cloud space, you have to touch it at some point, like if you're deploying machines and stuff like that. But we all kind of try to avoid it at a certain point because there are multiple reasons why bash kind of sucks. I mean, stick with me because obviously this is about bash, right? And I ended up writing bash, so stick with me. But we all understand bash sucks because, you know, it has a lot less modern programming kind of constructs that we're used to. Error handling is kind of meh. The syntax is kind of meh. Like anytime you kind of get to the point where you need to start writing functions, you probably should just use another language. This video is about having a good time and learning some things. In my other video, I created this graphical user interface basic, like, I mean, it's really aggressive to say graphical user interface, but it is technically that, in bash, in my shell. It was really fun. It was a cool experience. So I was curious what it would be like to create this same thing, but in a better programming language like Go. And what would be the differences? Like, what does it actually look like? Is it more lines of code, less lines of code, all kinds of stuff. So at the end, we're gonna actually grade these things side by side. And we're gonna do that based on a few basic criteria. One, I mean, the obvious, we're just gonna see which looks better. In line with the whole saying, I don't know if you all heard it before, beauty works better. I like things that look good. So we're gonna do that. The next one we're gonna gauge is just kind of time it took to write it. How long was it? How long did it take to write it? What were the actual lines of code difference for similar functionality? And then we have a few things like around the scalability thing. I want to think about how would, if I was doing this on a team, how easy would it be to add features? Because that's a big problem with like these long bash scripts that you'll find in these old smelly organizations. It gets gross really fast and it's really hard to maintain, which is why you go to another programming language amongst a bunch of other reasons. So yeah, if you stay to the end, we'll talk about some of those things. But for right now, let's go ahead and jump into it. All right, so for those of you that didn't see the last video on actually creating this basic GUI with bash, this is it. I just have a few functions that do some basic stuff, like get some info on our disk, understand how much memory our system has, and what user is currently logged in, with some basic echo statements that display our menu, read user input, and then we have this case statement down here, which actually evaluates all of our potential responses. Throw that in a loop, continuously read that, and now we have the semblance of a graphical user interface. Let's go ahead and run that real quick. I can just do /menu, and you see it pops up here. Cool. I can hit 2 to see my available memory. Pops up there in top left. Great, 64 gigs, awesome. Hit enter to continue, and I can keep kind of going through this, and press 0 to exit. Cool. What I want to do is write a similar program in Golang. So when I was looking around, I saw this Tview Golang thing. Let's throw that up for you real quick. Golang situation here, which is basically a similar type of thing, except way more advanced than my bash script as far as capabilities go, but allows me to kind of use these components to build these terminal-based user interfaces, these graphical user interfaces in our terminal. This is what we want to do, so I was like, hey, we'll try it out. It's funny, this was definitely a lot more involved, and I think it states kind of the point of when you use bash scripts, because it was just really simple to do what I needed to do in the moment. It just very quickly becomes annoying as you have to build out a bash script. But this, and like with a lot of stuff like this, it kind of gives you a ton up front, even though you maybe only need a little piece of it. So let's go ahead and jump into writing this, and then we'll test it out and show you what's up. All right, so first thing that I want to do is I'm just going to make a directory here. We'll just call it CLI again, cd into CLI. Then I'm going to do a little initialization here with go mod init, and then do github /devhulk/ is it called Tview, do that thing. And then we'll create our main.go. Awesome. Hit it with the package main, okay, lead up line. This is a thing. Do a test, go run main.go. The next thing that we really have to do here is import our Tview situation. So let's go ahead and do that. You can do that with go git, looking at the link here, github.com/revo/tview. Do that thing, fantastic. And then we're gonna open back up our main.go. Now we can start actually messing with our Tview situation. This is where it starts to get fun. First thing I'm gonna do is I'm going to create and initialize my Tview app just by doing app, assigning that to Tview new application. All right, that should import Tview, sweet. Then I can do a bunch of stuff here, but what I kind of isolated as I was going through this was they have this list capability that's really good that I think will serve our purposes, because again, our goal is, hey, we're taking a look at this from a sysadmin point of view. I want to see how much memory is available. I want to see how much disk space I have available and what user is currently logged in and doing the thing. So Tview has this list element. In the wiki, you can see list here. And this is kind of what we want. I want to be able to choose some options, right? And then do something based on those options. And we have an example here that we can do. So I think we should take this and then start iterating on that. All right, you know, a little copy paste, but now we have to figure out what it is we actually want here, right? Because we need to fix this. So the first item, we can have this be kind of a placeholder, I guess. So just do like tell the people what they need to do. Select an item from below type of thing. Do a little ellipses there. And then I'm gonna leave the explanatory text done, and I'm gonna change this to M as kind of like a menu. I still want an A though, so I'll copy that, throw the A in there, and then we'll say get available memory. We'll do that as an option as A, and then I'll leave the explanatory text blank again for now. So we want to get available memory. We want to get available disk space. So we want to get available memory, get available disk space. And then the last thing I think I wanted was to just get the current. And Golang has different ways of doing this than the simple commands in Bash. So we'll have to figure out what the Go way of doing these things are, which there should be standard libraries for that stuff. And then we have this quit down here, which I like, and we don't really need this for item. Should be able to delete that. Now this is interesting. This add item, if I go on that, says okay, yep, accepts those things. Add item calls insert item with an index of -1. I remember reading, I think that's the last thing, like it calls add item and it adds it, basically just appends it to the end of list. And it looks like what's nil for all of these other add items, this one actually has the callback function here and has given us an example of stopping the application, which is what we need for that quit functionality anyway. So that looks good. Let's go ahead and run it and test it. Do go run main.go. This looks pretty good. Now if I start selecting stuff like A, B, C, who quits out, that makes sense. So now we have to actually do some stuff. So as I go along, I kind of just want to, you know, make my code a little cleaner. This is essentially our options menu. So I want to take that and put that in its own function. So let's just throw that in a function up here. We'll say func, I don't need function. Let's just call it menu, I guess. Keep it simple. And then I'll paste that in there. List here. And then we'll return the list. Guess I could do that. But then again, I need the app. I should probably take in the app, or I could make it global. I mean, we can just take it in, it's fine. But we also need to do a return here. So let's grab that, return the tview.list. Might not even need to return it, but we'll just do it right now. Change it as we go. And then here we'll take in an app, and that is of type pointer to tview.application. Do that too. All right, that should work. Now list here, I should be able to do list and then equals menu, then pass an app. Boom. That looks like it's happy now. We just keep it a little simpler, and we'll make changes to our menu. I have a feeling we're definitely gonna have to separate some files. I'm trying to keep it simple because, again, the bash script, I think it was like 51 lines, but the bash script was all in one file. But I can already tell that we're kind of gonna end up with multiple files with this. Let's do go run main.go. All right, sweet, it still works. A, B, C, all right, cool, yeah. Now the next thing I really need to do is when I hit this add item, that callback function looks promising. Maybe it'll allow me to actually do something. But I think there's another better way to do it with this that I saw, which is this set changed function. So if I can do list.set changed function, which is pretty cool. You can see here a set change function sets the function which is called when the user navigates to the list item. That's really what we want to do. And we need some sort of function here that does that. So the type of function we need is this guy here. And this is really the purpose of this, is to set the response for selecting an item. So I'll just say set response, and then this is what we got. So that should work. And then I should just be able to say set response here. Now in my set response, I have some data in my parameters. I'm getting the index, where our list item actually is. I'm getting the main text, the secondary text, all the stuff that we set up top, which makes sense. And then that shortcut item. Now I'm thinking this, I mean, to keep this simple, we could really just do like a case statement here. Switch statement, case statement, whatever you want to call it. But I say let's do switch, and then we can switch. Do we want to switch? No, we could switch the index, but I say switch. Let's switch on the, because I think that'll end up reading a little better. So we'll say switch shortcut, and then we'll do opening of my case. First one was M. Gotta do single quotes because of rune. And then I should be able to do like, I think there's probably some type of setter, I would think. You know, I could use a global on that list. I mean, I don't love doing it, but I'm gonna want to have to do something here like list dot set blah blah blah. And right now it's just at the scope of my main function, so I might just do this. I might say list there, and then this is return what my tview.list, and we'll just declare this globally. I mean, cry about it if you want, but this. All right, so let's do var list, boom, is of type 2 list. Then we're setting it without the colon here. Great, that works. So now I should be able to access my list dot, yeah, should be able to do, and I bet they have a bunch of setters. Yeah, they have setters here. Set item text, that looks promising there at the bottom. Set item text sets an item's main and secondary text, panics if the index is out of range. Okay, so we're not setting the secondary text right now. What we could do is we could set the secondary text with the result of what we're trying to have. So let's do that. We'll set and we'll take in the index, which we have access to that now. So I'll be able to do index here. We'll do the main string, which we'll just pass in that main text because we want to keep that. And then the secondary, we'll say this is for M. We could probably just leave that. I mean, well, let's just test it out first. So let's say select, that could work. And then we'll do a default, I think default case, right? Which is, let's do fmt.println. That is not an available. This might work, this might not. Let's see. Should work. Go run main.go. Okay, so if I said M, oh, see, it said that's not an available option. Oh, but it worked there. I had to I clicked off of it and then I hit M again. Well, let's add the available. Let's add the other statements and see if there's still a problem. Do a little troubleshooting. So I'll do this. We'll say case. Because really, you should never have to hit the first one. It should just be placeholder text. That's what I feel like. You placeholder, but whatever. Let's try it out. So here we got main text, and then I'm just gonna say what I want to implement. Like implement. What is this one? Available memory? Yeah, available. But it does feel better. It feels like I'm doing something I'm actually supposed to do. And then C is get current logged in user, so implement. All right, let's test it out. Go run main.go. We're in here. A, B. That works. It's just when I press M, if I press M first, that seems to be a problem. We'll deal with that later because for the most part it works. So let's say main.go. Okay. We have our options here. Now what we need. So I found this memory kind of helper library. We're going to use that. We'll say go get github.com/pbnj. That's really pb&j. That, okay, good. That's added. We'll probably I probably feel like I should have like a handler function, little handler function, right? We'll do func mem handler. Maybe that works. And then we'll do m equals total mem. And I want to convert that to gigabytes because I know this gives back bytes. So we want to convert that to gigabytes, which is basically just dividing by 1024 three times. We'll do a little helper function. We'll just say bytes, 2 bytes. We'll take in a number, and that'll be a v4 because it's turning, and then we'll return. And then I think it's just, we just return I divided by 10. Yeah, there's probably way better ways of doing that, but I think that's what happens if I want to get gigabytes. So I can get gigabytes now. I should be able to by saying bytes, 2 gigabytes. M, and then yeah, I should be able to just return B, and then that should be 4. So that works. So now I should be able to do this. I added my item, go down to my case statement, and I should be able to run here like, I forget what I said already. Our mem handler, right? For mem equals, clean that up, right? Now it wants a string, so we'll just do a little sprintf, fmt.sprintf, boom, hit them with the mem, and do a little format string, boom, that value, because whatever. Now if I press A, boom, 64. So now, prettify that a little bit, go here, we'll do a little, just add gigabytes there, from main.go, A, 64 gigabytes, get available memory. We're sysadmining it up. Let's freaking go. Too hype for a basic sysadmin app. Got a couple more handlers. I think my file's already getting big. So right, we have to do this disk one. I anticipate the user one being easy because I think I've done something like that before in Go, but I don't think the disk one is going to be that easy. Like we might actually have to define our own types and stuff like that. So I'm gonna just do that separately. Preemptive strike here. Let's open main.go. Yeah, we'll do disk space next. Open up disk, package main. Just run it with that the star.go, that star.go. And we're gonna do some things. We're gonna do some things here. This should be fun. All right. So first thing, because I want the status of my disk. I want status, and we can use syscall. So let me create this. I'm gonna create disk status. Struct. We're going to put all for all of our available disk space, and that's going to be uint64. We'll do used, which will also be a uint64, and we'll do the free, which will be a uint. And I mean, we should be able to knock this out in one function. Let's do func, and we'll say D, which is pointing to disk status. So we'll have to declare a disk status, and then this will be a method function for that. We'll say disk usage and provide. I know you have to provide a path with syscall, but we'll verify that in a second. All right, so we have fs. We're gonna do fs equals syscall boom dot stat fs underscore t. Yay! Declare that bad boy. All right, now. This point, I'll do an error. We'll do a syscall stat fs, the path, which yeah, we're gonna need this. Yep, because it requires that path and then stat. So I should be able to do path, which I don't have currently coming in, and then pass fs, probably a reference to fs. Then that should be good. So then I should be a path string. That'll be fine. And then the basic, if nil, then return error. Let's go. I probably should return if I want to return error, huh? Makes sense. Now we get to set some stuff. So I should be able to set now d.all, which is going to reference fs.blocks. And we're going to multiply that by 64 b size. Okay. And for all of you that are wondering, yeah, I do have this part that I wrote before. Just so you know, like this isn't all off the top. I felt like that just had to be said. Like I wrote it this morning. All right, d.free equals fs.bfree. The reason why though I'm typing this out like this is because I feel like it helps me when I watch coding stuff where people are actually building it out. So that's why I decided to do it this way. Let me know in the comments if that's not ideal, but it helps me when I'm watching people code. So we're gonna do this. We're gonna get the free space. D.used. I did freestyle some of the stuff at the beginning. It's a little different than my reference code, but yeah, I'd say probably at least 70% I've been referencing back and forth. And of course, we can get the use this space by subtracting the free space from all of the space. Makes sense. And then I should be able to return nil. Boom. Great. So now if I go back to my main.go, I go and I look at disk handler. I don't have a disk handler actually. I have a user handler. Maybe we'll keep this pattern though of doing like a disk handler, a handler for every case statement, so I can keep this case statement as simple as possible. So let's do that. I'll do a func disk handler and then disk status, disk reference disk status. Boom, instance of disk. Now I can do my error and call my disk at disk usage with the path, which is just going to be my root path. I'm gonna pass in there. Then normal Golang stuff. If error equal nil, blah blah blah. Log.fatal. All the things being my error. I did do some things with constants to make the conversion from like the bytes to gigabytes a little bit easier. So we'll add that now, even though it's funny because I'm still using that other helper function, but we'll say bytes equal 1. We'll say KB equals 1024 times B, and megabytes 1024 times KB, and we'll do gigabytes equals 1024 times MB. We're gonna use these consts to actually convert all of my disk stuff. You'll see here in a second. All right, so I can say disk now, and I can just do colon equals disk handler. Call that bad boy, it returns my disk status. Then I can do my sprintf again. All right, so we're gonna display all of our kind of information. We're gonna say, hey, this is the disk all space, all the space available. V, we're gonna convert this to gigabytes. Then we're gonna display our use space, do another %v to that in gigabytes. And then we're gonna do the same for our free space, do v bytes. Now I just pass in all the things. So this is about to get real. All right, bear with me. So I'll do an int, that should work. Let's go ahead and test that out quick. Quit, I go. Oh, didn't like it. Oh, because I got to do a go run start, I go, because I created another file. All right, let's see. A should work, 4 gigs. B, boom, let's freaking go. I don't know why, like I wrote this morning, and this is like, I'm still excited about it. Now we only have one more. We only have one more to implement. I know the video is getting long, but bear with me. We got one more, then now it's expecting me to return a string, so I just want the username. I can get my username by doing user.username. Boom. Now all I have to do is return my username. Love it. So now this should be pretty easy. Go down to my disk, use my user handler. Handler returns my string. I should just be able to say fmt.sprintf. I'll scroll down a little bit. You guys can see the fmt.sprintf, and then do current user v, and then pass in my user, which would be you. How many lines of code is this? Just in this file is 95. That's way more than our bash script, but let's go ahead and run it. Go run star go. All right, hit A, use memory. B, I got, yeah, that's right, 926 gigs, use 713 for 12, that's cool. And C, my login user, Joe, yes, me. Sweet, it works. And I mean, I think it looks better, but let's go ahead. We'll get into the grading, and let me know how you all will grade this in the comments as well, because I think it could be some interesting conversation, especially for those who are like heavy into the bash script. All right. So I mean, it was a lot. It was honestly a lot more. Okay, but let's break this down. Let's break down the grading based on kind of what I've seen. When it comes to beauty, I think the Go app kind of takes the cake. It just looks a lot nicer. It looks a lot more well put together, right? If you look back at what I showed you at the beginning, it was, it was a little rough, but it was so simple. It was only like, 51 lines, right? So there's the trade-off. And that's the thing with all this tech stuff, is you're gonna have trade-offs. The next thing is kind of like, how easily could I add features to both of them? The bash script is gonna be a lot more challenging to continuously add features, let alone add them as a team, right? It's just, there's not a lot of good language constructs. It's gonna get messy really quickly. there's no need to really do it. Like, I think there is some modern things. There are some modern things that you can do to make Bash a little more scalable, but I still give it to Go or any general purpose programming language here, just because of the annoyance, right? And plus, you don't have a lot of people that are really experts in Bash, right? Which took longer to write. Honestly, the Bash script wins hands down. I mean, it was like half the code. What was the stats? The stats ended up being, the Golang app was like 124 lines of code, and the Bash script was 51 lines of code, which is really, I think, the most powerful case for Bash in a simple script all day long. Like, you're not gonna have to write as much to get a very similar thing done. It might not look as pretty, but it'll get the job done until you actually get to a point where you need something more scalable, like a general purpose programming language. But yeah, those are my thoughts. That's kind of how I grade it. I think I would still lean Go, but I'm not gonna give up Bash just because it, like I said, it's just really useful at certain times to just throw some commands in a file and get some stuff done. But I'm super excited that I learned about this Tview thing. I think I'm gonna mess with that a lot more because that's been really cool. Anyway, let me know your thoughts in the comments, like, comment, subscribe, all that fun stuff. See you on the next one.